So this is slide 5, prepare presentation. We're going to explain the Xbox method. Okay, so let's pick one of the last questions that we had. X squared was one of them. Let's pick one, not that one. Let's do x squared plus 10x plus 21. Okay, x squared plus 10x plus 10x plus 21. Okay, so these are broken down to 3 different parts: our A term, our B term, and our C term. Now the idea of factoring, okay, what factoring means. Okay, factoring is all about breaking down into multiples. Okay, just a really basic example. If we have 12, that is the same as 2 times 6. I want to basically divide it into parts. Multiples are divisible portions. They're little division chunks. Okay? And it only works a certain way. This one has a very specific answer, whereas 12 has more than one answer. I can have 2 times 6. I can have 12 is equal to 3 times 4. I can have 12 is equal to 12 times 1. I can make them all negative. But factoring a trinomial or a polynomial only has one possible solution. Okay? So when we break down this Xbox method, and we do this, and we have our A times C up here, our A times C and our B term, we're actually kind of jumping more towards the middle and to the end than it being the first step. Okay? So just because we place these here, these allow us to test our solutions. Okay, so if our solutions are, we know that our solutions for this one, because it was the last problem that we did, is going to be x and x, and then let's do this in a different color. We had plus 3 and plus 7. Now what we're doing is we're looking for these two numbers. Okay, when we look for these two numbers, we know that eventually they will multiply. Okay, if you're talking about FOIL, it represents the L, the last portion, and that's going to represent our C value. Let's write this out as FOIL. So FOIL, which is last, this is going to represent our C value. Okay, and our C value is this last one in red. Okay, when we multiply A times C, let's do the middle one. Our B value, this one in the middle, this B value is actually the two middle terms, first and then outer and inner. Okay, outer and inner, outer and inner represent our B value. Okay, so this is going to represent this bottom portion down here. And then that last one, the first one for first is going to represent our A value. Okay, that's this one, x times x. Now the reason why I do it this way is because it allows us to get the multiplication part and the adding part. The adding part is going to be when I add these two together, because these two middle terms will be like terms. I have 3x and 7x. I have to be able to add those two together. Okay? So these two numbers, in this case, we have 21 on top and 10 on the bottom. Okay? I'm actually splitting this number. I'm going to split this 10 into 2 parts. Okay? And those 2 parts are outer and inner. This is our outer and this is our inner. Okay? And that's where it's going to be split up here. This is the outer term, this is the inner term. It doesn't really matter, they're actually interchangeable, but it might be a little bit clearer if I write it out. So outer and inner, I'm eventually going to add them together. Okay? So in this case, it's going to be 3 and 7. So the outer term, 7x, inner term, 3x. And we're going to rewrite the whole thing in order. Our A term, which is going to be x squared. Our B term, our outer and inner, which is going to be 3x and 7x. And then our last term, which is going to be 21. So all I did was split this 10 into 2 parts. And since they all have x's, and these two both have 7s, I can separate into 2 multiples. Okay, I'm going to extract them into 2 sections. Now, the other way that people have taught were always factor by grouping. So I figure factor by grouping is great, and the Xbox method is actually the same thing. If we put it in order this way, I'm going to group these two and these two, these two and these two. Okay, factor on grouping actually takes out whatever is the same. So that way I don't have anything that's similar in there. Okay. So if we do this, we make our box. And we have x, 3, and 7. And these represent our factors, x plus 3 and x plus 7. That middle term is broken out to outer and inner. And the outer and inner are factored out by GCF, so that way they fit. It's a really confusing explanation. Sorry. But it works. Okay? Or just slide 5.
6.
This is 6 already?
6. 7.
Okay, so the challenge question shouldn't be too bad. It's not that challenging. Good.
Are you recording?
Yeah, I'm recording.
Oh, okay.
Okay, so it says the huh? Oh, am I on the wrong slide? Or
The next one is make connections.
Oh yeah.
Your footage.
okay, so this is a challenge problem, and I'm missing make connect. Is this one make connection? This one?
This is the next one.
Okay, so I'll do the challenge question later. At the end? Okay.
Whatever you want.
Okay, at the end is a good idea.
I'm just trying
Okay.
to yell so people can hear me in your video. Yeah.
Okay, ways of thinking. Making connections. Okay, take notes about factoring a quadratic. Huh. Okay, so factoring a quadratic equation. Do you know how to do it?
What?
Let's open up the notebook. Okay, you're gonna click here, and okay, we'll take notes. Okay, so when you hit the hint button, what does it say?
Ask it back to me.
Okay, so let's look at an equation. We'll write down factored form, and we'll try and figure out what the solutions mean. Okay, so question number 1: how does factoring help with finding solutions of a quadratic equation? So what I'm going to do here is I'm going to draw a graph, and we're just going to discuss what it means. Okay, here's our graph,
Thank you.
and here's our parabola. What do these 2 points represent? Solutions, right? So those 2 points are our solutions. Okay, if we know that, what else do we know about this line?
X-intercept.
Okay, we call this the x-intercept. Okay, what do we know about the value of this line? Okay, we'll call this zeros. Okay, now you can also say that that is y equals 0, because that's the y value of 1, y value of 2, y value of -1, of -2. This one must be y equals 0. Okay, so how does factoring help find the solutions of a quadratic equation? Now let's go back to that original equation we had earlier of y or f of x equals x squared equals x squared plus 10x plus 21. Is that what it was? Plus 21. And let's go to the factored form and see what we can do with that factored form. Now that factored form was x plus 3 and x plus 7. And what should this equal now so I can find its solutions? What should I make this? Okay, so I'll make this equal to 0.
Yeah.
Now, if this equals 0, how do I solve two numbers that will make this equal 0? Okay, so let me simplify the way this equation looks. I have one number, this number, okay, times this number. And it must equal what?
0.
It must equal 0. Okay, now let's pretend that this number here equals 1,000. What number is this
0.
to make this equation true? 1,000 times what will equal 0? 0. So I know that if I write it like this, no matter what this is, I know that this number here must equal 0. Agreed?
Agreed.
Okay, now let's change the possibilities. Let's say, actually, yeah. So that, let's change the possibilities. That means, let's say the second number was 1,000. What must the first number be in order for this equation to be true? Not negative 0. There's no such thing as negative 0. It must be 0. Okay, now the one thing that doesn't change for either one of these equations is that either this first number here must equal 0 or the second one must equal 0. One or the other. That first number or that second number. So what I'm going to do is I'm going to set each number equal to 0. Okay? So I'll set this first one, x plus 3, and I'm going to make that equal to 0, because that will make this equation true. If this was equal to 0, it would be 0. If I switch the possibilities, if I put the 0 here, okay, the other possibility is if I had x plus 7 equal to 0. Either one of these possibilities, my answer will equal 0, and that's what I want. Okay? We actually have a name for this exact situation. We call it the zero product property. Every time I multiply by 0, I get 0. Okay? So zero product property. So in order to find these solutions for question number 1, let's type this out. I'll type this out so the words will match what we're writing, and I'll do this in a different color so it's not super confusing. So we know this is the answer. How does factoring, so in factored form, the numbers are, oh, sorry, not the numbers. It should be the factors are all multiples. Therefore, multiplying by 0 will give us a 0 or solution. Okay? So if I set it equal to 0, then I will have an answer. So this is represented, this idea is represented by these two things right here. Okay? And those are my solutions. Very, very easy to find out. I'll minus 3 here, I'll minus 3 here. X equals negative 3. Get the variable by itself. Done. Minus 7, x equals negative 7. Variable by itself. Done. My two solutions. Okay? Now sometimes you're only going to get one solution. Okay? Sometimes you get two solutions, but only one of them is going to make sense. Okay? Questions on question number 1?
No.
No?